And welcome to Tomorrow, Orbit 10.42 for Saturday, November 11th, 2017. My name is Benjamin Higginbotham, coming to you live from the Star Ship Benterprise. I'm also joined by Tim Dodd, the Everyday Astronaut, and a Jared Head. Jared, what kind of news do you have for us today?
Well, I'm going to be talking about a bunch of asteroids photobombing the universe.
And I'm going to be talking about SpaceX experiencing a small failure with one of their engines this week.
And for our main topic this week, we have commercial crew updates and what we're expecting for 2018. Stay tuned. Tomorrow begins right now.
Good morning. How's everything up in the sky? Stand by.
Now, before we get started with news from this coming week, I did want to give a huge shout out to all of the patrons of Tomorrow who have helped make this specific segment of this episode happen. These are people who've contributed $10 or more to this specific episode. To find out how you can help crowdfund the shows of Tomorrow, head over to patreon.com/TMRO. All right, we'd like to get started with some launches. And Everyday Astronaut, you've got us set up this week for that. So tell us what we had launching first this last week.
Yeah, well, we're going to start off with a new segment called Watch Tim Slaughter Pronunciations of Everything, because we're starting off with a launch out of China with a Long March 3B from their Xichang launch base in China. So let's check this out. And this happened at 11:45 UTC, and China successfully lifted two Beidou navigation satellites to a medium Earth orbit on top of their most powerful rocket, the Long March 3B. This is the first time China's launched a Long March 3B since they had a failure of June just this year. And that failure was due to a roll control error in the rocket's third stage, which put the Chinasat 9A television satellite into a lower than planned orbit. This was the 41st launch of the Long March 3B, with only one failure and two partial failures. An important note that I want to point out about China launches is that they launch from the middle of China, not next to the ocean. So this means, and this launch is no different. We already have footage of where the pieces of rocket fall after they separate. We already have this interesting footage. This is from just the launch on Sunday already. Locals found this giant chunk of rocket, and I just think that's insane.
Just hanging out by the river.
Just hanging out. And this is another example. This is a previous one, but this is one of my favorites. It just shows toxic fumes pouring out over the people.
Don't breathe the smoke.
They say it smells like fish.
Don't breathe the hydrazine. Everyone, stand back. It's just insane to me. I just wanted to point that out because that's one of my favorite things about these Chinese launches. And, last week I mentioned that I feel like the Delta II rocket is one of the most Kerbal rockets of all time. If you don't know what Kerbal Space Program is a fun computer game. But to me, there's nothing more Kerbal than dropping parts of your spent rocket boosters on top of people. So, China, you win the Kerbal Award. So, yeah, that was a success.
All right.
Other than the falling in a river.
Your next launch, Tim, you had a launch for the Moroccan government.
That's correct. So next up, we have a launch from the Moroccan government that took place Wednesday, November 8th at 1:42 UTC, which was 8:42 Eastern local time on Tuesday night. So let's check that out.
4, 3, 2, 1, top. À image P80. Décollage.
That baby takes off so fast. Now, this was a reconnaissance optical imaging satellite named Mohammed 6A, which launched on top of an Orion Space Vega rocket from the Guyana Space Center in Kourou, French Guiana. The Vega is a solid rocket fuel rocket that stands about 30 meters tall or 98 feet tall and pushed the 1,100 kilogram satellite into a 620 kilometer high polar orbit. Now, all 11 launches of the Vega rocket so far have been successful, so 100% success rate, good job. But little was known about the satellite before the launch. It was only known by its code name, MN3513, and we only found out who the satellite's end user was just last week. So this is congratulations on a 100% success rate with this rocket. And notice how great they have an awesome animation. I made fun of Orbital ATK last week with their animation, but ESA or Orion Space, that's a great looking animation. So congratulations for success and for a good looking webcast.
Yeah, I'm enjoying the fire that came off the back of that engine. That was a real time rendering of the fire. Looked really cool. Mm-hmm. Let's pass it on over to Jared over at Station 204, talking about getting photobombed in astronomy. Jared, what the heck?
Yeah, every once in a while it kind of happens, and we just kind of deal with it because we get a little bonus out of it, like I'll be talking about. So the Hubble Space Telescope, it's one of the most productive instruments of anything that we've ever made as humans. And there's been a recent survey that's been being done by Hubble since 2013 called the Frontier Fields. This is basically pointing Hubble at really big galaxy clusters and taking in as much light as possible and using the gravitational lensing of these galaxy clusters to look beyond the galaxy cluster and see things that are further away, right to 450 million years right after the Big Bang. So we're talking looking back over 13 billion light years away. So really, really far stuff. And these frontier fields, they've actually changed how we view galactic evolution. We found that galaxies formed a lot earlier than we initially expected. They provided us those views of gravitational lensing, and that can actually help us nail down just how much dark matter is in a galaxy cluster. And then these images themselves are just absolutely breathtaking as well, especially one like this, like we have up right now, where every object in this image is a galaxy, and because of the gravitational lensing, some of the light from those galaxies is actually smeared out and warped. And we're seeing galaxies in this image that are 4 billion times fainter than what the lower limit of the human eye can see. But sometimes closer neighbors to the Earth will photobomb these images, and those would be asteroids within our own solar system. So this actually happens quite a lot when Hubble is trained to take these frontier fields along the plane of our solar system. And in this image, the asteroids are basically those streaks of light that you see there. Now, you think this would be really annoying to us astronomers, especially those trying to study cosmology and the evolution of the universe. But actually, this is really a bonus with these photobombs, because for every 15 hours of exposure in Hubble's frontier fields, we'd end up finding a previously unknown asteroid. So not only did we get incredible science out of the frontier field program, but also looking at these images, we were able to find new objects within our own cosmic backyard here in the solar system. And out of all of the frontier fields that Hubble did, we ended up getting about 100 asteroids that were previously undiscovered, and several hundred more that we knew about. And we basically got really good data about the orbits of those asteroids as well. So that's sort of one of the bonuses that ends up happening when you do studies like this, is that, hey, not only did we get a really great data about the early evolution of the universe, we also found some things that could potentially be hazardous that we would just rather want to keep a good eye on and track as effectively as possible. So it was a really fun study. So
Awesome. Thank you, Jared. A quick dumb question. So we're going to eventually retire Hubble. And we're going to move it over to James Webb Space Telescope. But the sensor suite on James Webb is different than Hubble. Are they still going to be able to detect things like this and do things like this on James Webb as opposed to Hubble?
So James Webb is going to be looking in infrared light. And as we look further back in the universe, the light is shifted more towards the red end of the spectrum. And some of the furthest objects, that light is actually shifted into, it's so red that it's shifted into infrared. So with James Webb, we're estimating we're going to see about 200 million light years beyond what Hubble is capable of doing. And also right now, Hubble's really healthy right now. It's exceeding the expectations from the STS-125, which was the repair mission done in 2009. So actually what's going on potentially is that we may have Hubble and James Webb both operational at the same time. And if that happens, they can actually do studies together and potentially even do what we call interferometry, which is where you take two telescopes that are far apart apart. You combine their light, and you basically make a telescope as big as they are far apart. Now, James Webb will be about 1.6 million kilometers away from us. They're going to drop it in Lagrange point 2, which is, or Earth-Sun Lagrange point 2, which is behind the Earth relative to the Sun. So I don't think they're going to get resolution from like a telescope 1.6 million kilometers across if they do the interferometry, but they will definitely get what we would call parallax data, which is basically the ability to look at the relative positions because they are so far apart. And these instruments are so precise, we'll actually be able to look at some objects and get very precise distances to them, and also maybe see what we can do in combining both of those types of light together. So some really cool science if both are operational at the same time.
That would be really cool. We just got to get James Webb up and operational to make that happen. That'd be awesome.
Yeah.
All right, let's head it on over to head on over to Space Mike. Space Mike, you almost got by without talking about SpaceX, but that's not going to be a thing. Space Mike. Oh, well, look what I did. Tim, the everyday astronaut, the other Space Mike.
Jeez.
I know I'm no Space Mike, and I never will be. You don't have to keep reminding me. But you're exactly right. I almost made it the entire show without talking about SpaceX. But unfortunately this week, we don't have the best news to report, but it's not that big of a deal. But last weekend, SpaceX was they experienced a failure of one of their Merlin engines. That's their engine that they use for absolutely everything. They were just doing a standard test down there at McGregor. They have a test facility down in McGregor, Texas. Now, to lay some context here, SpaceX actually fires every single one of their engines that flies. It goes down to McGregor, fires on its own, then comes back, gets integrated onto the stage, then goes down and fires again as the whole stage, then gets shipped to the launch pad and fires again for a short static duration. So SpaceX fires these engines all the time. I mean, we're talking about, out of the 45 or whatever Falcon 9 launches, times the 10 Merlin engines, because there's an upper stage engine. You have to consider how many engines they've fired altogether. If each one's been fired about 3 times per launch. So that's a lot of engines, a lot of data. But here's what's happening. They're currently working, and this is not footage of that. This is just footage of what a test fire looks like of the Merlin engine. And now they're currently working on the newest iteration of their Merlin engine, and they're working on it for this upcoming Block 5 of the Falcon 9. And now this Block 5 will be a little bit more reliable, hopefully. It will also be upgraded for thrust. And the big thing is they're hoping to fix. There was some concern over the cracks inside the turbine of the turbo pumps. So they're addressing that issue. So hopefully future Merlin engines will not have any issues with cracked turbo pumps, cracks in their turbo pump housing or in the turbine. And we'll see. So that's what they're working on right now. So they're just kind of sitting there going nuts with this stuff, trying to really hammer out all the details before they get ready to fly people on it. Because this engine will be, this upgraded version will be on this Block 5, which will be the ones that carry people to space, which is very exciting. But here's all we know. We don't know a lot, and it's honestly, guys, it's probably not a huge deal. We're just hearing about it because we have an ear to the ground at all times on all these things. But basically, they were loading up oxygen, and they sent it through all the cooling channels and into the chambers and all that stuff. And it seems like there may have been some small leak. They weren't even ready to test fire, and it sounds like the liquid oxygen may have come in contact with something. And all it takes is a little bit. Liquid oxygen, when it comes in contact with just about anything, will turn that almost anything. If it has any kind of carbon at all on it, it'll pretty much explode. It'll start burning because it's in a pure oxygen environment. So it could have been something relatively small. And that being said, it sounds like no one was hurt. Nothing really got damaged too bad. The test stand should be back in about 2 to 4 weeks. So as this was an engine for the Block 5 qualification testing, this does not affect any of their launches currently on Block 4. So there's still going to be a launch next week. There's still a bunch of Block 4 launches in the end of the year. I think at least probably 4 more launches this year. This does not seem to have any effect on that, so don't get too worried for those of us that are, watching every second of this stuff. So,
Awesome. Yeah. Thank you so much, Tim Dodd, the Everyday Astronaut. And for those wondering, because I did screw up and said Space Mike. Space Mike is back out again this week. We hope to have him back soon. So because people are mentioning that they miss him in the chat room, we miss him too. But hopefully he'll be back soon. But we love Tim Dodd, the Everyday Astronaut, as well. And we'll see how many times I screw that up throughout the rest of the show. It's gonna be fantastic.
Awesome.
All right, let's send it back over to you, Jared. You're talking about Jupiter at this point. So what's going on there?
So in mythology, Juno was the wife of Jupiter. And one of the things that Juno did is that Jupiter was quite, how should we say, prodigious in his lovers that he had throughout history. So Juno, his wife, would often have to lift a veil that Jupiter would put forth to try to prevent Juno from seeing what he was up to. So it's very fitting that a spacecraft called Juno is now orbiting Jupiter and trying to get some of the secrets of the largest planet in our solar system. But we're not just using Juno, we're actually combining observations from other spacecraft out there as well. And specifically, we're using NASA's Chandra X-ray telescope and the European Space Agency's XMM Newton telescope as well. And they found that not only are there X-ray hotspots at Jupiter's north and south pole, which is actually what you would expect with the interaction of the solar wind and the magnetic field, but we've actually found that they don't line up with each other. And in addition to that, they act completely independently of each other as well. Now, scientists are going to be using Juno to examine these X-ray pulses that are seen coming from the south pole of Jupiter. They actually come in 11-minute cycles. And with Juno there, we can actually study them in much better detail than we can manage even with Chandra and Newton around the Earth. And these X-ray emissions that come from Jupiter's north pole, they're very erratic, they're not as energetic, they brighten and they dim, they have no consistent pattern, and they're completely independent. Now, the current hypothesis is that this could be occurring due to the tilt of Jupiter's magnetic field relative to the actual tilt of Jupiter itself. And there's also other hypotheses that are suggesting that we may simply be seeing a bias in observation because the north pole of Jupiter is much easier to see from Earth than the south pole of Jupiter is. So they're going to continue to do studies with Juno at Jupiter and also Chandra and XMM Newton in orbit around the Earth. And this should provide us some clues as to what's exactly happening with these X-ray hotspots over the north and south pole of Jupiter. And if not clues, then hopefully the outright answers themselves as to what exactly is happening and what processes are causing this. So,
awesome. Thank you so much, Jared. All right. We're going to take a quick break. And when we come back, we're going to be talking about Commercial Crew 2018 and what's going on in 2018. So stay tuned. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And Tomorrow continues. Now, before we get into our main topic this week, a shout out to all of the patrons of Tomorrow who've helped to make this specific segment of this episode happen. These are people who've contributed $10 or more to this specific episode. We also have our Orbital subscribers. These are people who've contributed $5 or more to this specific episode. To find out how you can help crowdfund the shows of Tomorrow, head on over to patreon.com/TMRO. All right, so for the main topic this week, we're going to be talking Commercial Crew 2018, as well as some of our predictions into 2018. I'm actually going to hand this baton over to Jared because both Tim Dodd, the Everyday Astronaut, and myself are remote, which makes it a little bit hard for me to maintain this. So, Jared, take it away.
So we've got a lot of things coming up in 2018, and probably the most exciting for us is the hopeful payoff of the Commercial Crew program. Now, this is something that NASA started quite a while ago, and when NASA actually started the Commercial Crew development program, there were a lot of question marks. There were a lot of, is this actually going to work? Can private companies actually step in and provide cargo and crew transportation to the International Space Station? And now that we're quite a ways along in the Commercial Crew program, we actually have the answers, which is that yes, private companies can do cargo, and it would appear that everything is set for 2018 to be the year where private companies also start taking people, crews, to the International Space Station as well. And I'm going to go ahead and ask Tim Dodd a little bit if he can give us just a brief little background about some of the things that we're kind of looking forward to in 2018 with commercial crew.
Well, let me give just real quick set the stage here. Don't forget, for those of you that don't know, the two people that have won contracts to send humans to the International Space Station from Florida, so from the United States for the first time since 2011, is Boeing with their CST-100 Starliner, and that will ride on top of a ULA Atlas V rocket. And then SpaceX has their Dragon capsule, their version 2, which is their first crewed version, and then that will be riding on, of course, on top of their mighty Falcon 9, which does everything for them. So, so those are the two people that will be sending people to the International Space Station. And so far, we've had some. Now, correct me if I'm wrong. I actually didn't remind myself all this stuff, so I'm just going off the top of the old brain, which might not be the best idea, but. So far, SpaceX in 2015 did their launch abort system tests with their using Super Dracos, which are mounted to the sides of the Dragon capsule. So we have that out of the way. They've also done some parachute qualification testing. Boeing has done parachute qualification testing. And I think Boeing still has to do their launch abort and their in-flight launch abort. So does SpaceX. Those are some things we're going to be seeing. What else? What else do we need to talk about as far as what we're? I guess we need to see 7 flights of the upgraded Falcon 9 before they consider putting people on it. I believe because they don't want it to be changed recently and then put people on top of it. So we have to have 7 flights of the Block 5 Falcon 9 as well before we see people get on board. What else do we need? What else is there?
So like a week and a half worth of flights then?
At this rate, yeah.
Thereabouts.
No, I think that's part of the point. I think we're due to conflict of interest, I can't talk about SpaceX very much here, but I think that's part of the point is that both SpaceX and Boeing are very, very close to being able to send crew from American soil back up to the International Space Station. And while we have long talked about this on the show as one of those pivotal moments, 2018 seems to be the year where this is all going to happen. It's going to be very, 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 very cool and very, very exciting. I'm curious as to who's going to go first. Currently, it looks like SpaceX is going to go first, but Boeing's a little more secretive, or at least a little bit harder to get some of the scheduling information out of Boeing. So I'm not entirely sure where they're at in some of their demo stuff. But it's going to be very awesome to watch some of these new pivotal things. And when you look at what this enables in the future, it's not just sending humans to the International Space Station. It's then using this technology to send humans further than low Earth orbit, something that we haven't done since the 70s, going to the moon and then eventually going to Mars and beyond, as the old Constellation slogan used to be. So I think that's what I'm excited for, and I think that's kind of what we're looking forward to in 2018.
Yeah, and just to kind of talk about the schedules real quick, just to kind of remind everybody of it. Boeing's current schedule with Starliner says that they're going to do an unmanned test flight in June of 2018. They'll then do a crewed test flight in August of 2018. And then their first contracted crew delivery, known as USCV-1, which I believe stands for United States Crew Vehicle 1, is tentatively scheduled for December of 2018. Now, for SpaceX, with Dragon version 2, they're scheduled for an uncrewed test flight in February of 2018. They will have a in-flight abort test at Max-Q sometime around April 2018. And then following this, they're going to do a crewed test flight to the International Space Station no earlier than June of 2018. So those are kind of the timelines of things. 2018, as we were saying, is sort of going to be that year when everything finally comes together with this. And it's really great great to see this happening because the commercial services contracts began back in 2006. So this program has been going for a decade now, and it was originally just for cargo, and then they added on crew right around 2010. That's when the crew development began with commercial with, I believe it was specifically called CC Dev at that time, commercial crew development. We've got all these incredible milestones going to be happening this year. And we actually do have a question from the chat room from Lur, which is that isn't in-flight launch abort optional as a test? Can either of you speak to that as to whether in-flight abort is a option or if it's a requirement for commercial crew?
From what I know, I think they're right. I think it actually is optional. I don't know why I think that, but that's a great question. Actually, if anybody in the chat room does know the answer for sure, let us know. But that is going to be a really exciting test to watch because I don't know if anyone watched. Blue Origin did a kind of a similar in-flight abort test of their new Shepard. It was really cool, especially as we have reusable boosters, to see the capsule pull away and abort and land safely, but so did the first stage booster. And I don't know if, and we can't promise anything like that for sure with SpaceX when they do their launch abort flight, but there is the chance that they will be able to recover and safely land both the Dragon capsule and the Falcon 9 first stage, which would just be so insanely epic. I want that to happen. But don't plan on it because don't forget the vehicle. That's the point where the aerodynamic pressure is at its absolute peak. So as soon as you take the aerodynamic capsule off of that rocket, all of a sudden now that first stage is experiencing with the inner stage all of the aerodynamic forces. So there's a really, really, really good chance that it'll just rip the stage apart, which sucks that you're going to have a multi-million-dollar piece of hardware getting thrown away, just like the old days. Back in my day, we threw rockets away. But it just goes to show how quickly we're seeing this stuff change, and it's just like unfathomable that we're going to just throw a whole first stage away. But that is what SpaceX plans to do, and they most likely will lose that first stage. But if they don't, it will be amazing, and I can't wait. So.
Yeah, and I just want to talk about a research paper that actually came out this week, which talked about the commercial cargo, specifically commercial cargo from the Commercial Crew Development Program, which basically said that comparing cost to space shuttle, commercial cargo has saved a ton of money. The study showed that with shuttle, which carried a multi-purpose logistics module to take cargo like what orbital ATK Cygnus and SpaceX's Dragon send up to the space station, it was $272,000 US dollars per kilogram in order to send it up on shuttle. But with orbital ATK Cygnus, it's $135,000 per kilogram. So it's half that. It's half that cost. With SpaceX, it's $89,000 per kilogram. So it's almost, it's literally 1/3 of the cost that shuttle was with getting that cargo up there. Obviously, you don't carry the tremendous amount of cargo that the space shuttle could carry in a single flight, but you're literally halving and thirding the cost with it. And that really shows a great benefit for the commercial cargo program that was done. And it shows that this program is a huge success for NASA and everything that it gets to work with. And now we get to see how much it'll cost to start sending people to the International Space Station, which, correct me if I'm wrong here, either of you, which if I recall right now is about, I want to say $72 million per seat on the Russian Soyuz spacecraft. I want to say that's...
I thought it went up over 80 million at this point, isn't it?
Yeah, it's somewhere
per seat,
ballpark in that area where it's a little expensive in order to send people. Literally, as we like to say, it's literally your weight in gold is how much it costs to send a person to the International Space Station on the Soyuz. So I'm really looking forward to seeing how much the costs for Starliner and Dragon version 2 are going to be with that as well. So should be particularly interesting with that. So go ahead, Ben.
So here's another thing. Go ahead, Tim Dodd, the Everyday Astronaut.
Okay, well, and don't forget, we're currently talking about current cost savings. And one of the things about the space shuttle that ended up kind of killing it in the long run is how it took us so long to really realize the true cost of refurbishment and all the man hours behind every single flight, you know. And we have a pretty darn good understanding of how much it costs to launch crew or cargo and soon crew. But the big thing is we're not even including reusing the boosters yet, such as the Falcon 9. Of course, the Boeing plan with the Atlas V will not include any reuse. The Atlas V is a fully expendable vehicle. But imagine in a couple years, again, NASA is obviously experiencing a fair amount of confidence in SpaceX's reusability, since they will be using a reused Falcon 9 on their next cargo mission, CRS-13. They're going to be using a reused booster. So I would love to see, you know, if they can start doing that with people, it'll bring the cost down even more. And we're going to see that finally start to play out. And that's awesome. So I think the cost savings will just become more and more and more apparent. So I would love to see it almost come down by a factor of 10 from the space shuttle. I don't know exactly if we'll get there, but for sure we can make a big improvement from even a third. So.
And if I can derail this ever so slightly, you know, we're talking about commercial crew, but I think another thing that's going to happen in 2018, and this is pure speculation, but I think we might start seeing Virgin Galactic flying humans into space. Now, maybe not paying customers, but at least having a human cross that boundary and making it into space. And that could be kind of a game changer as well. And what we're seeing is all of these different types of companies putting humans into space and helping to drive these costs down. So, you know, we're talking earlier about, you know, what it costs today, which is radically less than what it costs in shuttle. But as we look at these new technologies going up there, these different ways of doing things, we can see these costs come down even further. Now, you know, Virgin Galactic is not a orbital company, so we're not going to see a Spaceship 2 make it to the International Space Station, but we can start to see maybe some of that technology blend into other things that enables something else to help reduce those costs. So I think that's going to be exciting for 2018 as well, assuming that's correct, right? You know, I have no inside information there. It's, you know, we've been saying this for a long, like every year since this show's been on, we're like, this is the year, but it feels more real this time.
Yeah, and I kind of want to piggyback on that a little bit because there are a lot of experiments that are wanting to be done by colleges that either require more time in microgravity than you can get in a drop chamber, which is somewhere about 3 to 4 seconds. But they don't necessarily want to put it in a CubeSat to launch on a rideshare into space, because that may end up being too expensive for what they actually want to do. So a company like Virgin Galactic, which will give you a microgravity environment for, I think, something like 5 minutes, that may end up sort of adding a little bit of a revolution towards studies of what we can do, because not every experiment is going to require you know, you to go all the way to orbit to get a microgravity environment. Sometimes you just want to do some things. I remember, was it Blue Origin who flew basically like a box of rocks on one of their flights? And yeah, and like a lot of people were sort of joking about the box of rocks flying around and seeing how
I don't remember the box of rocks.
They showed an experiment that was I don't know exactly what it was, but it was some kind of college experiment that had like some kind of collision experiment with a bunch of rocks. And they did it for, I think, for free or as some kind of demonstration of what they can do for colleges and stuff like that, which I think is really, really cool. Yeah,
and that is sort of an area where we're looking at how rocks on the surfaces of asteroids would interact. Areas with really low surface gravity, which is something that's not particularly well understood, which you need more than 3 to 4 seconds in a drop chamber for, but you don't need to put a box of rocks in orbit in order to test out in microgravity what they're going to do. So this to me, that is where the real suborbital space flight, that's where the real revolution is going to come in being able to do studies like that. So, do you have something, Ben? We both got something to say.
Well, I was going to say, to be fair, it's not just 3 to 4 seconds because you can do a parabolic flight, and that's going to give you a microgravity environment for longer than 3 to 4 seconds. But it's not a very long time. I know Vax has done a bunch, and I don't remember what it is, but it's like less than 30 seconds, more than 10, so it's somewhere in that range.
Yeah, and did you have something to say, Tim?
Yeah, just piggybacking on what Ben said earlier, we're looking at going from no launches from the United States that are carrying people into space at all, like literally zero, to all of a sudden having for sure SpaceX, hopefully by the end of the year, we can't say for sure until it happens because there's always potential for delays, and Boeing and Virgin Galactic and Blue Origin is very soon behind. I think they're saying 2019 for Blue Shepard. But we're going to be within, all of a sudden, I think from the first time that we start sending people into space, within about a year time frame, I bet there's going to be about 4 companies sending people to space, which just is going to be crazy. The amount of, the public interest that's going to come out of that is going to be great when we actually start sending people on top of, rockets from the United States into space. It's just going to be a huge media storm. And to me, that's awesome. Just we have it. It's all happening kind of all at the same time within a 1-year window-ish. It's going to be awesome.
Yeah.
So, Tim, did you call it Blue Glenn? Did you call it Blue Glenn?
I'm sure I did. I have no idea what I said. Blue Glenn sounds super cool.
That sounds really cool,
Blue Glenn
actually.
Origin Buster.
So Dan TC24 in the chat room has a very interesting question that we're talking about here, which is that testing vehicles and systems has to be expensive. Are the contractors expected to foot the bill for these, or do the development milestones include compensatory, boy, I blew that one, funding to offset this cost? Who wants to talk to this one? Who wants to talk about that? So Tim is pointing at Ben.
No, all right, yeah. So the contracts, it's not cost plus, meaning it's not one of those things where you say this is what our costs are, and if you want to add on more things, it's going to cost you more, so you're incentivized to make it as expensive as possible. It's milestones based for these COTS and different programs. So basically, you have certain milestones you have to meet. When you meet that milestone, you get some money. Now, how much it cost you yourself, what your expenses were to get to that milestone, that's not the responsibility of the government. That's the company's responsibility, be it Orbital ATK, SpaceX, whoever else is competing, right? Pick any company. Mm-hmm. So Boeing would be, actually in this case, would be SpaceX and Boeing. So, if SpaceX or Boeing spends more money to meet milestone A than they make on milestone A, that was them needing to spend more money. If they spend less money, that's them needing to spend less money. But when they meet the milestone, they get the reward pot. I'm not sure what to call that, but they get the milestone funds at that point.
They get the bonus. So yay, you did.
Yeah, exactly.
You did the thing. Here's some cash. So kind of how it goes.
Mm-hmm. You did the thing. You get. Yeah, that's exactly correct. And then once they're done, so you've got these milestones to get you to a flyable point, and then it's like, okay, neat. Consider it a taxi service, right? So now I want to send 3 astronauts up to the International Space Station. You grab Uber and you say, send 3 astronauts to space station. It says, cool, that's going to cost you however much money, 10 million, 20 million, I don't know what it costs. So it's going to cost you that much, Apple Pay, and off you go. But they don't get to charge necessarily more or less. It's kind of it's a taxi service at that point.
So it's a commercial Kruber, if you will.
Commercial Kruber, yes.
For lack of a better
That's the
term.
shirt for the show, yeah.
So we've got a question from Jim Burr on YouTube, actually, which is predictions on, I'm assuming that's a sort of a type of Bezos, starting space tourism.
No, I'm Benzos. It's me. I'm Benzos, and I'm starting a space tour in Sikokini.
You're a Benzos. Okay. So does everybody kind of want to do their predictions on what's going to happen with space tourism in 2018? I mean, should we just start with you, Ben, and then go to Tim Dodd, and then I'll say something? So.
Sure. Yes, I think. Well, I don't know if Blue Origin, Bezos, so Blue Origin, will be ready for space tourism in 2018. Although it does feel Man, they're really hard because they're very secretive. So
Yes.
even in their more open state, they're still very secretive. So we really don't have a whole lot of information as to what's going on there. I have little doubt that Blue Origin is working to send humans to space in very large numbers to live and work in space. Right? They are working to open up cislunar space, and they're working diligently to make that happen. What year that happens will that be 2018? I don't know. I would no longer be surprised by anything Blue Origin does. So if Blue Origin tomorrow said, we're going to launch humans to the moon and set up a colony in a week, I'd be like, cool, I'll buy that. Right? That's the point I'm at with Blue Origin. So I'm hopeful that they do something in 2018. I would love to see humans living and working in space in 2018. But on Blue Origin's timelines, what are they? The tortoise in this, the tortoise versus the hare. They're slow and steady and methodical. Yeah, exactly. So they're very methodical on what they do, and I think they're going to very much so take their time, make sure it's like they want it to be, and they'll go when they're good and ready to go. So whether that's 2018, 2019, 2020, I think I'd be lean closer to 2020 for them. But I really have no data on Blue Origin whatsoever, so it's near impossible for me to actually predict.
Mm-hmm. Tim Dodd.
Let me answer a few questions because I'm not entirely sure if Jim Burr's question was about the starting date or the price. He just says on Benzo starting space tourism. We know that Jeff Bezos and the New Shepard is their space tourism little capsule. We know that that's pretty much ready to go. I don't actually understand because they've flown that thing 5 times with huge success. And I don't really know why they're waiting more than a year. It sounds like 2019 is when they're going to start accepting flights on their New Shepard. At what price, we have no idea. My guess, I'm thinking they're going to want to undercut Virgin Galactic, and Virgin Galactic comes in at $250,000 per seat. So I'm thinking it'd be really cool if we could see them around $100,000 or something a lot less expensive, just to really poke at the space industry and say, here's what we can do it for. Especially with their system, in theory, it might only cost the cost of fuel. And a few other checkouts and all that stuff. But it seems like the New Shepard does not require much refurbishment. It seems like a really solid system. So my prediction is I don't think we'll see space tourism with them until 2019. And then on top of that, I would like to think it's going to be cheaper than $250,000 per seat. And then my next prediction is as far as the living, working in space thing that Ben was talking about, their New Glenn, their orbital class rocket, which is huge. I mean, this thing is Saturn V size, basically. Is not slated to go online until 2020. They are working very hard. Their factory's almost online already out there at Kennedy Space Center. You can see this huge factory, multi-billion-dollar facility. They're not, when they say they're going to do this, they're definitely going to do this. There's no doubt that they're not just going to pull out and be like, never mind. They've invested already into it. They've been hot firing the main engine for that. Yeah, they're getting really, that's coming along. But again, I think their thing is slow footsteps or something, but ferociously, or slow but ferociously. That's their motto. So I love that. And to me, that's a very, very cool thing. So so I don't entirely know for sure if it's going to be, so 2019 is my prediction for New Shepard. 2020, they'll start launching New Glenn. And I wouldn't be surprised if they start putting people on top of New Glenn very soon after it starts flying, 2021.
Yeah, and
Gradium Ferociter.
What was that, Ben?
And what's that mean?
It's Gradium Ferociter. It's basically gradual with, what is it? Gradual with force, forcefully forward, something like that.
Nice. That's a pretty good one. I like it. Gradually, ferociously, Tarantula says in the chat room. So pretty good there. And I'm not in disagreement with either of you on this. It's like you said, Ben. They're very secretive, so there's not a lot of information that trickles out of Blue Origin. They have recently been a lot more open in talking about things, but overall they are sort of the Blue project, if you will, of the commercial space world. They, I know New Glenn was kind of predicted, but when they announced it, it also kind of came out of nowhere as well. So I'm
they're
kind
very
of
much
Oh, go ahead,
They very
Tim.
much do something, and then they're like, by the way, we did this like 3 days ago. It's no big deal. I mean, when they landed the New Shepard, I don't think anyone really realized that was technically, I mean, I don't want to get into the debate versus the Falcon 9's orbital dynamics and what it's all doing compared to the New Shepard. But they technically crossed the line, the Kármán line, with a booster, liquid fueled booster, and landed it vertically just a few weeks before SpaceX did. I mean, similar thing, but they did it, and then they told everyone like a day or two later with a really well produced video. No one had any idea this happened. All of a sudden, everyone's just like, wait, you did what? And you didn't tell us? You didn't invite the media? You didn't do anything? They're just like, oh yeah, we did that. And then, oh, we did it again. Oh yeah, we did it again. They just keep. And finally, I think it was the last live stream, the most risky one, the launch abort. They're like, oh yeah, you can join in on our live stream. We're going to live stream this one. But I don't think up until then, maybe it's the fourth one, they may have live streamed that one as well. But before that, they were just super. Yeah, we did this. Here you go. Watch it. Have fun.
Yeah, they did live stream a couple of them.
Yeah, Dudda's got a nice funny comment here, which is, our super edited video of our last test flight will be out tomorrow. We tested last Thursday. So
Yeah. Well, that was, to be fair, that's very old school Blue Origin. The newer version of Blue Origin was like, as they were kind of doing more of those test flights, they were airing them live. We did get to see them live, and we even got to see their launch abort or launch escape test, where the capsule broke away from the booster, and I expected the booster, the aerodynamic stresses on the booster, to just rip it apart.
Yeah.
But instead, like they flew apart, and then I watched as the booster started coming back to Earth, and immediately I created the hashtag Team Booster on Twitter, because I'm like, oh my God, this is amazing. So yeah, I think Blue Origin is, when they're ready to show you stuff, they'll show it to you in a really great and grand way. But if they're not, then you don't get to peek behind the curtain at all until they're ready to show you.
Mm-hmm. Yeah. So going to the chat room from Rebel Ace Friesland. So how many people will be in space at one time in 2018? 5 or more? How many people do you think are going to be in space maximum in 2018?
Well, we normally have 7 on station, don't we?
6. We have 6 on station. Right?
6.
Like right now, we have 6 on the International Space Station, and that's its max capacity at the moment. So,
plus, there's a chance next year we'll have 2 more taikonauts. You know, at any moment there might be 2 taikonauts on either their upcoming space station or just on one of their spacecraft. So there's 8. Plus, anytime there's space tourism, if those 2 things happen to align, you could be up to 10. You know, SpaceX will be, I think, just launching 2, maybe 3 astronauts on their first flight, but that will be a standard rotation of the International Space Station, I believe. Mm-hmm. So I don't think they're going to have more than 6 during those rotations. Although they take 3 up to 9, right? Or did they go down first?
My present understanding of the International Space Station crew expansion will be that when U.S. commercial vehicles are flying astronauts there, the crew will expand from 6 to 7. So they're going to add on 1 more astronaut, and 4 U.S. astronauts will rotate out at a time with that. Okay. So, or not necessarily U.S. astronauts, but basically the 4 astronauts that rode the U.S. crew vehicle up are going to rotate out.
Right. And
I can see us having 10 people in space.
Mm-hmm. Yeah, absolutely. I just wanted to throw some of these things out, which are some of the stuff that's actually coming up, if you will, in 2018. Which is that the SpaceX, the rumored flight from SpaceX to fly to paying customers on a free return trajectory around the moon is sometime, it's last we heard late 2018. I know you cannot touch this, Ben, so don't say anything, but Tim, what do you think?
I think that already got pushed to 2019.
Okay.
I feel like that kind of went in somewhere. I have that in my head that it already is 2019. I don't know why I think that, but I feel like I heard a pretty solid statement that they were waiting for something. And again, the Falcon Heavy will have to fly several times before they throw. And Dragon. I don't think they're going to send a Dragon capsule up on a second human flight out to the moon. You know, I think they'll want that to be a little bit further along in qualification testing as well. So.
Yeah, and kind of to take a question from the chat room and hand it to you, Tim, because you can't touch this. From Angry Young
I'll
Space.
sit here. I'll just sit here.
Yeah, just sit there and look pretty. From Angry Young Spaceman. To Tim Dodd, because Ben can't touch it. So when is the projected first launch of Falcon 9 Block 5?
Yeah, we don't know for sure. One of the things that we're hearing and thinking is that we're probably going to see it be the first test of the Dragon 2 as well. That's kind of some of the things we're starting to hear. So that would probably put it sometime maybe February, kind of spring, late winter, early spring, whatever the next thing is after winter. Yeah, so it's looking like probably February, March-ish. And it sounds like it's going to be very obvious when it happens. Mm-hmm. It's going to be a pretty big change compared to Block 4. So I think, yeah, like I said, if it all goes well, it sounds like it'll be the first flight of Dragon 2. So just keep your eyes out for that. People will probably be literally stalking the booster and literally stalking the Dragon 2 capsule and having an exact map and GPS coordinates of where it is at all times, because that's the internet.
Yep. Yeah, I've heard 3 possibilities for what flight could be the first flight of Block 5. I've heard the first flight of Dragon 2 could be the first flight. I've also heard that the in-flight abort for Dragon 2 could be it. I've also heard that the Iridium launch carrying the reduced number of satellites plus the Grace follow-on mission may also be the first out of Vandenberg. So throw it in the air and let's see what lands, I guess, is kind of how we're going to do this.
Real quick, to talk about Block 5 with the launch abort, I don't think that would be the case, because I don't think the launch abort will be on a full stack. I'm guessing launch abort will be on some form of first stage only, because they don't need the upper stage. This happens at max Q, which is around 1 minute of flight. Although it actually might be hard to get the exact right period of max Q with a smaller vehicle. I don't know how all that works, but I don't think they're going to need an upper stage and all that stuff. So it seems silly to me if you're just doing a 1 minute flight and to have an upper stage on it and waste that hardware as well, because that can't be recovered. There is no recovery of the upper stage. So it'd be weird to me if they flew Block 5 with just the first stage of it for the first time. That'd be a strange first flight of Block 5, in my opinion. But I could be wrong.
Yeah, we'll find out eventually. Also, a abort flight for Orion is supposed to happen in 2018 as well. They're using a modified Peacekeeper ballistic missile in order to test out some systems on Orion during an abort with that. Also, in Planetary Exploration. Oh, go ahead, Tim.
I just had a real quick question. I've looked for this answer, and I can't really find it. And if somebody knows, is Dream Chaser's abort system, is it also a pusher system? So to clarify my question for those that don't know, normally we see a launch abort tower, say on the Mercury capsule, the Apollo capsule. There's an actual tower that is on top of the capsule, and Orion has a launch abort tower. In case something happens, it pulls the capsule away, and then it jettisons itself, and then the parachutes come out. SpaceX's Dragon 2 has the launch abort motors on the side walls of the Dragon capsule, and I can't quite figure out what Boeing's doing. I feel like they have launch abort motors that are also mounted that are on the bottom edge of it, but I can't actually find solid stuff. Dutta says tractor rockets. I thought for Boeing. What are tractor rockets? My dad worked for John Deere. I don't remember him having anything to do with rocket engines ever.
Right, it's called tractor rockets. It's like the Gemini and Apollo launch escape systems.
Yeah, the launch escape system where you have the motor on top of it. So it's like a tractor. It pulls it away. A pusher system is anything on the bottom. That's sort of what, for what I know, Dragon 2, Starliner, and Dream Chaser will have. So as far as I know, Dream Chaser will have a pusher system with that as well. And then just a
tower. I haven't seen any renderings of a tower or any kind of system on the CST-100. Have you guys? Maybe I'm just totally missing it, and I'm a Dumbo, but Anybody?
Yeah, I haven't seen anything either. So, so as far as I know, it's a
I haven't
pusher.
either. Yeah.
Yeah, as far as I know, it's a pusher system for Starliner. But if we're wrong, someone in the comments will absolutely correct us. That's for sure. Also, just want to say real quick, in planetary exploration, what we have coming up in 2018, NASA's InSight seismology lander is going to launch and land on Mars in 2018. The European Space Agency and JAXA, Japan's space agency, they're going to be launching Bepi Colombo to Mercury. That's going to take 10 years to get to Mercury. But it's not going to take 10 years, but the mission's going to last 10 years. It takes a really long time to get to Mercury. It's going to take 8 years to get there. In addition to that, we have 2 asteroid sampling missions. They're going to arrive at their respective targets. Hayabusa 2 is going to arrive at Ryugu, which is an asteroid. It's going to take samples. It's also going to drop an explosive on the asteroid and detonate it, and then look at the fresh material
kill
on
it.
So yeah, it should be fun. And then OSIRIS-REx, our favorite backronym, is going to be arriving at asteroid Bennu, not Benny, Bennu. And it'll be taking probably a couple kilograms worth of material from the surface for return here on Earth in 2023. China, just as secretive as Blue Origin in some cases, it's going to be launching Chang'e 4 lander rover. As far as I know, that has not changed, even with the failure of the Long March and their heavy lift rocket as well. That is a lander rover that is being repurposed to attempt the first ever soft landing on the far side of the moon. In addition to that, China is also slated to launch their core module for their Chinese space station, the first of 3 very large modules. But of course, there's not a lot of news that comes out of China. They're even more secretive than Blue Origin, if that's possible. So yeah, it's a little bit difficult. So I guess just to wrap up the segment, any final thoughts from you guys? Because my final thoughts are basically that 2018 is going to be really, really awesome, and I'm so excited to see a decade's worth of work finally coming to full fruition, and actually going to be seeing astronauts head to the International Space Station on commercial vehicles. And I'm very interested to see who's going to get the American flag that's on board of the space station and bring it back for those bragging rights that was left by Atlantis on the STS-135 mission. So that's what I'm looking forward to the most. How about you guys?
Well, real quick, it looks like Greta has...
Go ahead, Tim. Let's do Tim.
Slide for us ready. Look at this. He found a picture of the launch abort escape system for the CST-100 Starliner, for Boeing Starliner. So it is a pusher system. Yeah, there it is. Now we know.
Mm-hmm. Yeah, and those engines are part of the service module as well. So they get used for some stuff on orbit. So
there we go. Now we know. That's great. Ben, you had some thoughts to finish up on.
No, I was just going to say, I agree with Jared. I think 2018 is going to be an epic year for space nerds. We've got a lot of stuff that's happening, and there's going to be a lot more. This is just the stuff that we know of. The stuff that's going to be announced in 2018 is going to, by all of the companies in new space, is going to be really quite awesome. And the thing to also not forget is that United Launch Alliance is working on Vulcan, and so hopefully we'll hear more announcements on Vulcan coming in there as well. So a lot of really amazing things coming up in 2018. I'm super excited.
Yeah, it's going to be a ton of fun, and especially with the science, I'm like super stoked about everything that we're going to be doing. So I cannot wait. It's so good stuff. It's such good stuff. Also, apparently we have something from the chat room just to close it out with. What does it say? Dada
is wrong.
All right, Dada is wrong. A very rare Dada is wrong.
Let me have my closing thoughts, Jared.
Oh, yeah. Oh, I'm sorry. Sorry, everyday astronaut. Go ahead and take it away. I thought you said, and then you like deloped to Ben or something. So go ahead.
No, because I talked about CST-100.
Okay.
I am now going to talk about my exciting thoughts of 2018.
All right, take it away, Tim.
I officially think that 2018, just to echo what Ben said, 2017 was a great year for spaceflight. We just saw a lot of launches. The cadence for 2018 all around the board seems to be increasing. There seems to be just a lot of things happening. We'll be seeing Falcon Heavy flying, hopefully fairly routinely. Hopefully we'll get a couple flights of Falcon Heavy. We'll be getting probably about 30 flights of Falcon 9, up from the 18 to 20-ish this year, depending on how everything ends up going. then we're going to be seeing humans flying into space again in 2018. I can't wait. You know, it's been so long for all this stuff coming. So it's just all going to come to fruition in 2018. And the future is just looking super bright from here on out. Because once the stuff's online, it's not going to slow down. It's a new system in place that's just going to keep going. So it's happening.
Awesome. So we hope you're looking forward to 2018 just as much as we are looking forward to 2018 as well. So thank you guys for this wonderful discussion that we had about next year, this year, now, on tomorrow. So speaking of more tomorrow, when we come, we're going to take a quick break real quick. And when we come back, your comments from last week's show. So stay tuned. There's more tomorrow right after this.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end.
T-minus 1 minute.
We've only just begun.
Orion is functioning perfectly at this point.
Come with us and explore tomorrow.
I cry every time. So welcome back to our final segment of the show where we talk about your comments from last week. But before we get to those, we want to thank a large majority of our supporters that we have, because we are a crowd-funded show. So we want to thank our Escape Velocity Patreon supporters. These folks give us $10 or more for the show. They get a lot of stuff. You can go to patreon.com/TMRO in order to take a look at what you get. We also have our Orbital patrons. These folks give us $5 or more for this this show that we get to do here. But wait, we also have our suborbital patrons, and I love that this is getting we're getting so many suborbital patrons now. But the text is really, really tiny, and you're going to have to stop and take the time in order to see your name there. Don't forget, grab your permanent marker, circle your name on your monitor there as well. You get your name during the third segment of the show, exclusive access to a multitude of things. And as we said, we are a crowd-funded show, so we do these shows because of what you allow us to do. You enable us to make these shows possible. We can't do it without you guys and the incredible support that the Tomorrow community gives us. So if you would like to help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. Hashtag forever grateful to all of you who definitely help us out. And even, as you mentioned, Ben, subscribing to us and liking our videos and other things like that is a huge help to us as well. And I'm always just, I cannot believe just how awesome our community is. It always blows me away every time I sit and think about it.
And civil too, civil.
Yeah, it's really a very good group of people in our community. And if I keep talking, I'm going to cry, and it's not going to end well for everyone. So let's go ahead and move on, talking about last week's show, Orbit 10.41, about the incredible Brooke Owens Fellowship Program. This is where before we talk to your comments from last week's show. So would you like me to be Capcom today? Okay, I will be Capcom today.
No.
Or you want to do
Well,
it?
that's actually all right. I'll Capcom, and then I'll toss it to you at the end. We clearly planned this well in advance.
Yes.
All right. So our first comment comes from YouTube. It's from Thomas M, who says, "I'd really like to see if SpaceX can land 3 first-stage rockets. This would be an awesome and a sight to behold." Yeah, I can't talk to that, but Tim Dodd, the everyday astronaut.
Yes, that will be. And we're going to hopefully see that here by the end of the year. So wait another 6 or 7 weeks, and hopefully you're going to see exactly that. Of course, if you're out in Florida to watch the Falcon, and this is in reference to Falcon Heavy, which will be 3 first stages basically strapped together. If you're in Florida, you'll only see the first 2 land, the 2 side cores. Most likely, depending on unless they do some crazy flight profile where the first boosters do something crazy different. But for the most part, it sounds like the side boosters will do return to launch site, and the center core will end up being very far downrange on the, of course, they still love you drone ship. So, yeah, we're going to see 3 boosters land within a 10-minute window of each other very soon. I can't wait.
Yeah, not only is that going to be really
and hear
cool.
them too.
Yeah, I was about to say, not only is that going to be really cool to see, it's going to be loud with that happening as well. And then we can have another big debate. Was it 3 sonic booms, or was it 9 sonic booms, or was it 6 sonic booms? I don't know. Well, I guess we'll figure that out, right?
It'll end up being 5, and everyone will be like, "Wait, how can it be 5?"
Hey, hang on. This is something that I just thought of. I just want to bring it up quick. The boosters, if they're 100, 200 feet away, will there be certain areas where the sound waves will crest and be like twice as loud as other places, like in geographic location,
and/or twice as quiet?
That's true.
And/or twice as quiet.
Yeah, that's
Some
true.
places
Very good
where you
point,
might almost be completely mute, and then your neighbor's house will be flattened by the sound waves. That would be crazy.
Did you all hear that? No, I didn't. So yeah, it's gonna be really great.
Right.
Why did you have your "there's a gator in the toilet again" voice on?
Because it's Florida. So that's my. I've never been to Florida.
Moving on.
That's what I think.
Moving on.
Okay, yeah, let's keep going.
YouTube, Scott says, "Mars is not hostile. You're hostile. No, you are simply not a Martian. Earth is hostile from a Mars perspective." Jared, I'll pass that one over to you. I thought that was an interesting way of looking at things.
Yeah, I mean, Mars sucks. Even to send electronics to, Mars absolutely sucks. It's dusty, and the regolith that makes up the dust on Mars is very fine, so it can get through just about every crack you can possibly try to seal up. In addition to that, the average surface temperature of Mars is about negative 80 degrees Fahrenheit. I would use Celsius, but I can't remember what the Celsius is off the top of my head. Shame to me. For that, it gets really cold at night. Also, a fun fact I learned just a couple weeks ago is that because of Mars's very thin atmosphere, the temperature differential from your feet to your head is immense. It's something like 120 degrees Celsius. It could be like 75 Fahrenheit at your feet, and it'll be minus 150 Fahrenheit at your head. It's ridiculous, and I didn't even think about that with that there. But Earth also sucks as well, because think about it, if we dropped you with like no supplies on just basically like the clothes on your back somewhere on Earth, most of the areas we would drop you on Earth, you'd be dead within a day or two. So Earth really sucks too. So doggone it, all these planets just suck. It's not good places to go.
And on YouTube, Hayua says, "That is true. There are 100% more bear attacks on Earth."
That's right. That's right. There's a very good graphic that shows a green area highlighting where bear attacks occur, and in Mercury and Venus there is 0% probability. At Mars, Jupiter, Saturn, Uranus, and Neptune, there's 0% probability. But if you go to Earth, there's a 100% probability for bear attacks. Yeah.
Don't forget, you'll be vastly outnumbered by robots when you land on Mars.
Yeah.
So there's a pretty good chance of a robot attack on Mars.
Yeah, there could be. Mars, I can't disagree. Mars is the only planet currently entirely inhabited by robots. So, yeah. So.
That's the shirt for the show. All right. Last comment comes from Joseph off of Patreon. So thank you very much for being a patron. A very practical question regarding SpaceX point-to-point. Couldn't they slow down above atmosphere to subsonic speeds? It would still be 1,200 kilometers an hour and come through the atmosphere, so the last 100 kilometers of travel would be slow enough to avoid a sonic boom. I'm getting shaking head no from Jared. I'm going to pass this to Dutta as well, because Dutta's really well versed in sonic booms and whatnot.
Yeah. So should we let Dutta answer this?
Hold on, I gotta push buttons.
He's pressing buttons. We're going to the empty. There's no one there. It feels so lonely in there right now.
It does, man. It's like quiet. Lonely. I don't think that's possible because of how physics works.
Yeah.
You would expend so much fuel. You would have to have like an insane amount of delta V in order to be able to accomplish that. So if this is a tiny little Earth and you want to go from this side here to this side here, you shoot kind of this way-ish and falling towards Earth, and gravity kind of gets you over to this side. In order to do something like that, you would have to make a much greater parabolic arc, and then you would have to do some sort of deceleration thing to stop your rotation around the Earth, and then just like stop right there and then be able to fall towards Earth on that side. And the delta V requirements for that are kind of insane and unrealistic. So I don't think that that's going to be a thing.
Yeah, well, I don't think so. Go ahead, Tim. Take it, Tim.
Well, even if you don't go on a higher parabolic arc, you'll essentially have to go into orbit or very close to it, literally with only a couple hundred meters per second within orbital speeds, and then still have enough delta V to slow down to subsonic, basically, before you reach the atmosphere. And then not only that, you still have to go through the atmosphere, which you'll be falling again. So you're going to be going from, say, 100 kilometers in altitude, subsonic. You'll have to keep that speed, so you have to be basically hovering that whole time to stay subsonic all the way through the remainder of the atmosphere, which is an insane amount of fuel and an insane amount of delta V to do that. So I don't think there is. But that being said, there might be a little tiny bit of margin to slow down a little bit more, a little bit higher, and help alleviate a little bit of those sonic booms. But that's total speculation. I really have no idea.
Yeah, atmosphere is free deceleration. So that's the way I look at it. It's,
use it
to your advantage, and the more you can use the atmosphere to your advantage, the less weight you have to carry. The less weight you have to carry, the more people you can stuff in your Big Falcon spaceship, and the more people you can stuff in it, the lower your costs can hopefully be for point-to-point travel. So. Yeah, you can do it. It's just that the penalty in terms of the weight of fuel that you have to carry in order to do it just makes no sense whatsoever.
You might, like for shorter point-to-point flights where maybe you don't need so much fuel, you might be able to use a little bit of that fuel to slow yourself down just a tiny little bit and push your sonic boom window a little bit farther away from civilization. And that might be a realistic thing for certain localities. Mm-hmm. Say if you're traveling to New York or whatever, you want to come in the middle of the night and you want to push your sonic boom a couple miles further out into the ocean, you might be able to do that a little bit, but it's not going to be an appreciable difference, I don't think.
Yeah. That's all. I think that's all we got to say. So.
All right. That's our show for this week. I'd like to thank everyone so much for joining. I also want to thank our ground support patrons for helping to make this specific segment happen. These are people who've contributed between $1 and $2.49. Once again, every single dollar helps. And to find out how you can help crowdfund the shows, head on over to patreon.com/TMRO. All right, that's our show for this week. Actually, Dada is off next week, so I will be back on station, but I will be directing the show, so that show will be an absolute mess. So I definitely suggest you watch live to watch all the mistakes. It's going to be fantastic.
Yeah.
And I'd like to thank everyone so much for watching After Dark. Up next.